Good afternoon, people. Welcome to another software engineering class. Can you hear me?
Yes.
Very good. Today we're gonna start our lecture with a little bit talk about your submission. Have you managed to submit the projects? Did you suffer any problems during your submission? Have you managed to submit it on time? Is there anyone who faced any difficulties through Moodle or some kind of difficulty during the submission? Okay, would you like to talk? What kind of difficulty you faced, if you have any? Just raise your hand, please, and talk. I can't read the chat messages all the time because I have several screens open in front of me. If you raise your hand on the participant panel, I can give you the right to talk. Yes, Abdul Samad has something to say. Yes, Abdul Samad, we are listening to you.
Hello, sir. Good afternoon, sir.
Afternoon.
We uploaded the PDF and source code before time, but we couldn't submit for some reason. It wasn't just working.
How late did you submit? Like
About
15 minutes or something?
About 2 hours.
Oh, 2 hours is a lot up to submit. If you are like 15 minutes or something, I could forgive you for submitting a bit late. But 2 hours is a very long time. I don't think the model servers were down for 2 hours because I went into midnight and checked the model and it was working.
Yeah, we actually didn't try it all the way to the 2 hours.
What do you mean?
I meant like we tried it for some time, and when the time when like the 11:59 passed, we waited for a while and then we came back and do it.
Like you waited for 2 hours? Come on. That's not very logical, is it?
No,
Yeah, I would see that as your own mistake, to be honest. If you were submitting it like maybe 15 minutes late or something, I would say, okay, you know what, 15 minutes is not that big deal. I might forgive you. But 2 hours is a lot. And this project was given to you quite a long time ago, isn't it?
Yes, sir. Yes, sir.
Yes, it wasn't like the last minute that I gave you. You had some time to finish it. And after this chapter, I will actually give you another project, which will be the final one. I won't give you more than two projects.
Okay, sir.
So it will be only two projects, and you will do basically work in the same kind of project, but this time you're gonna do the design. So you're gonna reverse engineer the project now. That is the focus of the second work. You will reverse engineer the project that you already completed. You will learn reverse engineering, and you will also learn to use these diagrams that we have been talking for some time. In the last week, we talked about, if you remember, we talked about activity diagram, and we solved an exercise about it. We said that this diagram is very similar to the flow chart, but there are some difficulties such as it can show concurrent activities. It is more focused on the data flow, and there are parallel processes that can come and leave as one process. All of these are discussed. We also solve an exercise and I uploaded it. I don't solve all of the exercises here. Normally, these should be taken out during the lab sessions because every week, if you remember, if you check up your timetable, we have 2 hours lab session every week. But because the labs are not being done during the online sessions, I just saw one exercise from each diagram and move on. because we are not covering the lab sessions. So in the last lecture, I draw them using the Lucid Graph software. You can also use other software such as Microsoft Visio, should you want to do this. And your second assignment, which I'm going to give it to you next week, is going to base on drawing graphs, okay? Drawing these documentations through using reverse engineering. And you're going to work exactly in the same group. So you're not going to change your group. You're going to work in the same group with the same set of people who completed the project with you. And this time around, you're going to reverse engineer the project rather than focusing on the GitHub or focusing on the aspects of agile software development. You're going to focus on creating documentation as if this was a very planned or organized project. You're going to reverse engineer it and create documentation. That is going to be the same project that we already completed, and this time you will focus on the UML. Now, we already discussed that in the UML we have 5 different diagrams. These are activity diagram, use case diagram, sequence diagram, class diagram, which you already know the class diagram, and finally state machine diagram. And as we discussed in the previous lecture, we already said that not all of these diagrams can be used in one project. For example, if you design an e-commerce kind of website where everything is based on PHP and Laravel, where user log in to do certain tasks, a state machine diagram is not necessarily something you need to show. Okay, so in this case, it is not something that you would draw in your project, but another project can be something like an embedded system, such as a calculator software, and in that case, a state machine diagram can be needed. So because the differences among the software projects, not every diagram is being drawn in the documentation. Let's move on this next diagram, which is called the use case diagram. Now, what is the use case diagram? A use case diagram is basically used to show the interactions of the system without getting too much detail, and it is majorly used by the management or to show this how the system functions from a big picture rather than focusing on the details, how tasks are carried out and so forth. It shows the interactions among the system using what we call as actors. These actors are external entities. They are not specifically living things per se, but rather a standalone entity that stands outside the system and they interact. For example, a cash machine or a cash withdrawal machine, such as ATM machines, can be an actor. Additionally, a bank franchise can be an actor, as well as the user can be an actor. So one of the mistakes that students make is that they automatically assume that actors are living beings, but this is not always the case. A use case diagram basically shows the interactions among the system. The interactions are happening through the actors, which they stand outside the system. It is the interaction themselves are called the use case, and they are shown with an ellipse. And the ellipses are actually being interacted with the actor. So every single ellipse would somehow directly or indirectly connected to these actors, which are represented as bubble man or stick figures. Let's look at some of the components of the use case diagram. There are some boundaries in the use case diagram, which is basically shows the boundary of the system. This is the scope of the system, where the system starts and where it ends. It usually shown in the use case diagram to show that the actors themselves actually stand outside of the system rather than inside. The other category is actors, which are the external entities. They usually stand outside the system. The use case are the interaction themselves, just as in the activity diagram that the actions start with a verb. Most use cases will start with a verb as well. Finally, there are two types of relationship that you can establish in between use cases. In order a use case to be connected to another use case, there should be a relationship in between. In use case diagram, we have two types of relationship. One of them is include, the other one is called extend. Now, we're gonna discuss about the include and extend a bit further, but just so you know, the include means that in order a use case to exist, it needs another use case to exist in the system. Simply like a child-parent relationship. So in order the child to exist, a parent should be existing in the first place. The extent relationship is the opposite of this. So it is kind of like these entities are interrelated with one another, but it is more like an add-on feature. So it's like they have some related fields, but they are also different systems. So it's like they do not directly depend on each other, but they are still linked. Such as when you go to buy a product, you can basically review the product as well. You can directly review the product, but it is something that you would link to the product category or product buy page. So we're going to discuss about the use cases now. The use case diagram is basically used to describe the system functionality in a horizontal way. They are a little bit different from the activity diagram because in here we can show what we call as the actors. This is the emphasis on the use case just to show how many actors are there and what are their interactions with the system. In the activity diagram, you did not have any actors, so we didn't know who was actually using the system at that time. We were just focusing on the flow of data from one end to the other and where this data is flowing in parallel, concurrent, or just as a single activity. In here, we are more focused on the actors and their interactions. So that, for example, if we have a user, a visitor in the system, we know that visitors can register, become users, and the users need to log into the system in order to use the features. Something like that will basically break down the actors. You know that you have a visitor actor, and visitor can only have become a user when they register. So this kind of relationship establishes you to find how many actors are there and how many of them will interact with the system in what functionalities so that you can focus on breaking down those functionalities. This is the perfect diagram to explain how your system is going to function to a higher authority who do not need to understand any details about the system, such as if you have a project manager but they do not know programming or how to break up these tasks, but you want to show how the system is going to interact as a whole picture. This is the perfect diagram. This is why when you, for example, go to a 402 jury for your graduation capstone project, it is often expected to show them an abstract representation of your system through using a USD, so that even if the people who have never seen this project before, they can immediately relate, they can immediately understand what is going on in your project because you made an abstract representation of it. They are also very different from the sequence diagrams, which is the next diagram that we're gonna see, because this kind of diagram, which is the use case diagram, does not have an attempt on putting a sequence of these interactions. So there is no order, there is no number of times that the system actions return, or even the errors themselves are not being displayed in the UCD. So remember that we always mention that these documentation is an abstract representation of the system. It is not 100% alternative version. You can see this especially in the UCD because UCDs do not show error handling. They do not show any order in terms of how these interactions will happen. There is no order and there is no error handling in UCDs. Any questions so far? Do you have any questions about UCD? No? No answer? Nothing? Well, basically, I'm going to continue. You should use UCDs to represent the functionality of the system, as I told you, particularly in a big picture to a higher authority, usually, or a team manager. And they are very well fit to circumstances where people can see all the interactions in one picture, such as what can administrator do, what the user, regular users can do in the system. These are all displayed in one picture. It is also suited to task description of all things that can be done with the system. In other words, in a big picture, you can show who does what with the system itself. So moving on, you should not use UCDs for displaying error exception handling, something I already mentioned, illustrating the sequence of steps that must be performed in order. Like I said in the previous slide, without even coming to this slide, I told you that there is no order in UCD and the error handling is not really something that is evaluated. It's not the priority in the UCD and it is not displayed. Let's look up the notations one by one themselves. First notation of the UCD is the actors, which are external entities that stand outside the system. I use the MS Visio examples in here because that is the software that we had in the lab. So basically everything that I created here based on the Visio, this representation of it. So what I did in here is that you can basically, according to the software you can use the actors themselves using a stickman figure. It is possible to use stick figures, or you can use a bubble man. These represent an external entity. One of the mistakes, as I told you previously, that the most students automatically assume that the actor themselves are actually living beings, like people that are using the system. But this is not always true, okay? There could be circumstances that the actor represents a non-living being or an external entity that another user interacts or shows the functionality, such as you can show a cash machine, how that cash machine is basically connected to a bank system. Moving on, it is possible to generalize the users, such as if you want to refer to the customer as the commercial customer, which is basically those customers that always buy stuff. You can do that within the notations of the use case. So you can automatically assume those things. This is not an often practice, but you might see it here and there. As I told you previously, it is possible that the use case diagrams are not always represented in the same way in every single software. Like the actor, there will be some differences, like the actors themselves could be stick figures, could be something else. It will still be named as the actor or external entity, but the figures itself could be slightly different according to the software that you use. So if you use a software and see completely different symbols rather than the ones that I use in here, do not automatically assume that those are wrong or this is wrong. It is just that this different software use different notations to refer to those uh, entities. Okay, like I said previously, these are de facto standards. There is no such standard in software development that we have strict languages or strict symbols to represent something. In one software, it could be an ellipse. In another software, this is a round rectangle, and that's okay. As long as within the software, it follows up the same pattern to represent the use case or the actors, that is just fine. I would prefer you to follow up these notations that I use in this specific slides because they are very simple to embrace. Like, for example, when you want to draw an actor, I would like you to use a bubble man or a stick figure. But very rarely, although very rarely, I see other symbols being used to represent actors and other cases as well. A use case is a single unit, which is the next notation, and it is a high-level behavior that is basically caused by another use case, or it is an interaction done by the actor itself. It usually starts with a verb. In order to connect a use case to another use case directly, there should be a relationship in between those use cases. So normally you would not connect a use case to another use case, okay? Unless there's a relationship in between the two. The association themselves are also called dependencies, are usually established between actors and also the use cases. This means that the actor is basically interacting with the system to do something. And that interaction itself is the use case, which is then broken down into subunits to refer to the functionalities. So basically, everything that you show here is a non-functional requirement of the system, such as the customer should be able to withdraw money. But then how you do this has to be broken down even further in order to achieve to that state. Okay, that is the core idea behind use cases, to basically visualize the non-functional requirements, and using this norm, you generate functional requirements, because all functional requirements actually come from non-functional requirements. There could be relationship between two actors as well, such as you can establish a bank and a customer, and the relationship in between is withdrawing money. And you can read it in either way. Customer shall withdraw money from his or her bank account, and the bank shall allow withdrawal from an account of a customer. So you see, you can basically read it in one way or the other. There is no order. When I say there is no order, this is what I was referring. You can read it from either of the sides. The relationship is still there, okay? So make sure to use the word in a way that you can refer to both actors if you want to establish a relationship in between the two. I also want to emphasize the use of shall and should here. Every single relationship that you establish should be written either with shall or should, because that is a requirement. You use the word should when it is not mandatory in the system, kind of like an optional thing, and or an extension, and you use shall when it is basically something you need to support. To be more specific, the include relationships usually written as shall, and the extend relationships usually written as should. Moving on, you can basically establish relationship between an actor and a subcomponent of the system. The relationships are not always established in between two actors. It is possible that there is another use case or a subcomponent of the system. For example, within the boundaries of the system, there could be several data sources such as a JSON web service, a database, a file system, and so forth. And if you want to show how the interactions are happening in between these systems through using actors, you can actually draw a use case in between. For example, the medical receptionist shall transfer data to a patient record system. Okay, this shows that the record system is some kind of data bank, whether it is a database or a file system or whatsoever, and the receptionist is basically transferring data there, and the transfer of data itself is happening in between the two. Okay, so you can also say the opposite: the patient record system transfer data to the medical receptionist. So you can read it from this side, it is possible to you can read it from that side, or you can read it from this side, doesn't matter. That is why I said there is no order. To basically remember once again, the main purpose of the use case diagram is to capture the software functionality requirements. And to do that, you need to basically draw the diagram itself. And the use cases actually are non-functional requirements because they have to be broken down so that you can achieve to a state to understand what are your functional requirements. Okay, so this is kind of like a practice that you can use to verify your functional requirements in the system during the documentation. So before I pass into the exercise one, do you have any questions? Did you understand why we use case diagrams? They are very straightforward diagrams, so I don't think there will be any big problems, but if you want to talk, let's just stop here and discuss if you have any problems. Okay, so if you don't have any questions, let's look at the exercise one. We need to model a use case diagram of a system that will allow teachers to register attendance of their students. So this is a exercise given to you. So what you need to do here is that you need to define the actors, who are the actors in this scenario, define the non-functional requirements and convert these into functional requirements, each one as a use case, and draw the use case diagram. So look at the exercise again. We need to create a case where teachers register attendance of the students. So when you read this, I highlighted them with a color coded the keywords here. You will see that there are teachers and there are students, and the use case itself is actually registering the students. So in that kind of scenario, we can basically think about how we can establish this. So I'm going to show you in a minute on how to do this. So basically, when you want to draw a use case like this, you need to name your boundaries, name the system boundaries themselves. So if you want to name the system, you can name it as the register system. And registering the attendance is basically your use case. Remember that the use case usually starts with a word. Your actors are teachers and students, and the relationship is established in between the two. Teachers register the attendance of students, or students register attendance for the teachers in the register system. So registering the attendance is the non-functional requirement, and this has to be broken down. And when you read the keywords, those become the functional requirements. Teachers take the attendance of the registered students, and students register to the attendance of the teachers. Okay, so this is how you break down the task. It helps you to visualize this concept, so you can generate these requirements for your system. Now you know that these should be done. Okay, so now that you should allow me in your system as a teacher to take the attendance, and you should also allow students to sign the attendance for the teachers. Okay, by drawing this diagram, you basically generate those requirements. Does it make sense what I'm talking about? Since no one is talking, once again, I am struggling and just talking on my own. It would be nicer if you actually contribute to this course and ask questions or discuss. Okay, once again, your awkward silence dominates the classroom. So I'm going to continue. There are two types of associations that you can establish in between the use cases. One of them is the include, the other one is the extend. I already discussed about this, but let's go through them once again. The include relationship is basically a standard case linked to a mandatory use of the use case. So basically there is a base case, there's the included one, and the standard use case cannot execute without the included one. So in order to make sure, in order one case to work, it needs another one to exist or run. That is the relationship. Okay, so in order for us to run a specific functionality, for example, in order to edit the profile of a user, the user should first log in. Without the login operation, they cannot edit their profile. So login is a must, is something that the user should complete alongside with the edit profile procedure. So they should be in their profile first of all in order to edit it. That is an example of base included relationship. There are examples given in here, such as if you want to get an authorization for loan, you can first, what you need to do is to first to go into a credit history check. So if you want to loan from a bank because you need money or because of some circumstances, such as you are broke because of a pandemic or something like this, you need to run a credit check. This means that you shouldn't have any loan in the bank or in any other bank in the centralized system, so that credit check should be completed before you take the loan. Okay, that is a good example of how include relationship works. The other relationship that we can talk about is the extend relationship. This is more light relationship compared to the include. Now include one is very harsh because in that one, if you don't do one thing, the other cannot run. In here, they can run, but they have some kind of connection. It is more like an extension of the other rather than it's a must. A good example to this is, as I told you, the review process of products. You don't have to go to the product list page in order to review the product itself, or even to go to the basket of yours. You can directly go to the basket and add the product, or you can go to the product list and add the product itself. The same thing is that if you want to review the product, there's always a link on the product list page, but it is also possible that you can go to the reviews and post a review there. So there is some kind of connection in between these three, but it is more light-worthy because they have their own existence. They're just extension of one another. For a basket system to exist, it doesn't need specifically a product list, not that specific product anyway, because a basket is its own system. It's something that exists in the system on its own. But what you use the basket is basically to add the products. So that is why there is a connection. So although they exist on their own, they are still connected to one another. This is called an extend relationship. So they are extending one another. Okay? And the way that the arrow goes also changes in extend and include relationship, which will give you a hint about the relationship. Because in the extend relationship, you will see that the additional functionality, the add-on, I will say, will go into the actual main page. If you go up, however, to the include relationship, you will see the opposite. You will see that the base one is the one that goes to the included, just as you see in here. The base one goes into there. Okay, this will give you a hint about the relationship and how it goes. So you will first check up the names and then look to the direction of the arrow, and it will give you a hint about the relationship. Here's an exercise, so let's have a look. Given the following diagram, generate the functional requirements of the system. So let's look at that. Hint, as it is an include, use the word shell. So this is something that I already mentioned. Whenever you use an include, we usually use the keyword shell. Okay. The student shall print their transcript after verifying student ID. So this means that student cannot print their transcript without the verification of their student account, right? Without verifying a student ID, without verified by the system as a student, how can they print the transcript? The same goes with the grades. Without logging into the SIS as a student, without verifying your student ID status, how can you check your grades? It is not possible, okay? So this is the main functionality that you are trying to achieve. This is what you want to do, as you can see. However, in order to do that, you must do something else. That means the base and included relationship. So when you go up in there to look at the base and included one, you will see that this is the base. Sorry, this is the base, which is what you want to perform. And this is what is being included. And if you go down, you will see the same relationship. This is the base. This is actually what you want to achieve as the student. This is what I want to achieve. But in order to achieve that, this has to be done first. Okay, that is the meaning of include and extend relationship. To summarize, use case diagrams give a fairly simple overview of interactions, so you have to provide a more detail to understand what is involved there or what is an extension. They are very useful to explain the system in an abstract overview, particularly to project managers or scrum masters or whatever, any other team leader, sorry. Usually they are described with some detail, but there is no order. Don't forget that. And as a software engineer, you can choose the most appropriate format depending on the use case. You don't have to use the format that I chose here. The format that I followed here is the visual format, okay? Hello guys, I'm sorry, but I ran out of time. So basically, each session has to be 40 minutes, and I ran out of time, and I'm sorry for it. I wasn't paying attention. I get carried away because I really feel passionate about what I described. I just got carried away. but technically I should be reminding myself that each session must be 40 minutes in Zoom. So just to summarize, what I was saying is that these are very useful diagrams to explain the overall structure, and you can choose the most appropriate format to show the use cases. The fundamental structure is there, but the format might change according to the software you use. In here, I used basically visual standards, but in Lucid Graph, I saw some differences. And it doesn't matter as long as you consistently use the symbols themselves, you should be fine. As before I move into the sequence diagram, which is our next diagram that we're going to cover today, do you have any questions?
Hello, sir.
Yes.
Yeah, I just wanted to ask about our project. Are we going to get some feedback on it before the end of the semester, or we're going to get both results at the same time for both projects?
Mm, I will check them and I will keep a feedback form, of course, while I evaluate the work. If you want, I can share it to you. I don't mind writing a small paragraph about the feedback. Okay. I will have to go through and test the software. If I don't see anything, consistent in the report, I will probably use the software before I go to the report itself. So make sure that the link for your software is provided there so I can check it. And of course, if you want to get feedback, I can provide this to you either as a written account, or we can arrange one-to-one Zoom conference and we can discuss it. Okay, it might be
Okay.
actually better if we do a Zoom meeting with your team if you want to get feedback.
Okay,
I used your software. You asked me to do a validation. I understand, and I couldn't get back to you. I'm so sorry, but at the time I was
yes.
running my midterm for CMP 112, and I have 303 students in that class because the university gave me the entire lecture. I was teaching only one section in that course, but they gave me 7 groups altogether. So it was the midterm date for that course. I was extremely busy. Even though I saw your email, I couldn't return you back on time. So I'm so sorry about this. But believe me, I am not very comfortable with this situation because my workload is maybe tripled because of the pandemic.
Okay.
If you want to receive feedback, of course, this can be arranged. It is, of course, your
Yeah,
I
of course.
understand.
When your workload is less, then we will receive a reply by email.
Towards the end of the term, my workload will be less because probably I'll be finishing my classes. So around the end of this month, I'll have less workload. But if you basically followed what I told you in the description of the coursework, uh, so everything would be fine. I use your software. The only feature that was lacking for me is that the UI wasn't very well established and I wasn't getting error messages. But apart from that, it seemed like okay. Also, I need to check the report. Okay.
Okay.
All right. About this chapter, do you have, because the next project you do will depend on drawing these diagrams. Do you have anything you don't understand?
No, it's clear.
Okay. So far, we covered 2 of the 5 diagrams. The next one is called the sequence diagram. The sequence diagram is probably the one diagram that will give you the most detail about the interactions of the system. This is the diagram that is appreciated by the developers the most because among the interactions diagram, this is the most detailed one. Now, the previous diagrams, one of them focused on the data flow, the other one focused on the actors. Now, the sequence diagram does both, and it does more than that. It actually can show you the order of the events now, and also it can show validation. So it is the diagram that the developers find the most useful, because basically this is the closest diagram to show the alternative version of the system. Okay, that is why developers appreciate this diagram more than UCDs. So let's go down and look at some of the differences. The sequence diagram is used primarily to show the interaction between system components and actors, as well as the interactions among the system components. The interactions in these diagrams have an order, unlike the use case diagrams, hence why they are called sequence diagrams. Developers typically think sequence diagrams were meant exclusively for them. This is, yes, true, because they find it very useful compared to the other two diagrams. And finally, organizations, business staff can find sequence diagram useful as well to communicate how the business currently works by showing a variety of business object interactions. So when we use the use case diagram, sequence diagram, it has some differences, because basically when you use the use case diagrams, they are often refined, which means they are detailed into one or more sequence diagrams. So because the use case diagrams show a very abstract representation of the system to an higher authority, they are broken down into two or more sequence diagrams. And as we discussed before, these are primarily useful to the developers. So here is the use case diagram representation, sequence diagram representation of a login interface. And as you can see, there are interactions in here that shows quite a lot of detail compared to the other diagrams. There could be multiple objects, there could be components in the use case diagrams, and there is also an actor, which is the user itself. And there are interactions that can be synchronous or asynchronous, which means that can happen at the same time consecutively, or it could be that if they are done one by one. So it is kind of a mixture of the activity diagram and also the use case diagram. When you look at this diagram itself, you see that the username and password is sent by the user to a login interface, which the developers should design and develop. When the username and password is received, they are validated through a user validation, and the details are checked from the database. The data is retrieved, user login verified, and user successfully logged in. In here, you see that the login operation is successful. And there could be another scenario in here that shows that the user failed to log in. So every kind of scenario can be broken down into sequence diagrams. So it shows you how many interfaces you're gonna design, and it will show the interactions among these components as well. So that bar, the green bar that you see on the screen, is actually the timeline. It shows the activation, what we call as activation, and you see in where the activations will happen. So the login interface is activated first, which then activates user validation, which then activates database. And the database activation, as you can see, is the smallest one. It just activates, checks data, and closes. This gives you quite a little bit of detail about how you're gonna design and secure the software, because as you can look from this diagram, your database shouldn't stay open too long or too much. Otherwise, the security of data will be threatened. Okay, So the timeline and activations also give you an idea of how you can manage these. So similar to the use case diagrams, there is an actor, there is an object interface. We call this object interface. We call this the actor. Well, they have their active and non-active status as well, and the activations are usually shown as a bar. The actors and the objects are integral part of the sequence diagrams. What you need to know here is that the actor represents a user or an entity, and the object itself represents an internal part of the system. The dashed lines under the object represents the timeline of an object. The actor and the objects can have active or non-active states. So if there's a bar in there that you see like this, it shows the activation of the user. And sometimes these bars are small, showing that they are activated for small periods of time. During the active state, the actor objects is interacting with other objects. During the non-active state, the actor and object is not needed in the system. It means it's not needed to be active. By looking at the timeline, it is possible to say which objects are frequently interacting with the system. So you can also define which of them would interact to which other objects on a frequent basis. So you'll see that the login interface will interact first, which then activate the user validation, and then it will go to the database. So most of the interaction will actually happen in here and here, and then the database. You know that the user validation is key here because it is activated and activated again. And the same goes for the user interface. For the database, it is relatively small. We don't usually look at the user because user is an external entity and it doesn't exist as part of the system. Moving on, the activation. The activation displays an active or non-active status, which we already mentioned. It is represented as a vertical bar. While this is not always the case, a user generally accepted to be alive at all times. Some diagrams show the bar like this. Some others I see that there's just small bars. And then when it is needed, they put, to be honest, it doesn't matter because user is not an integral part of the system. They're not something we're gonna code. They're not something we're gonna develop, so it doesn't matter. I see both versions. Some versions I see that they put the bar to the end, showing that the user is always alive and active. And some others, they just throw a small one and then they throw another one when the user is needed to interact. Both versions, I will say, are correct. For the messages, there are 4 types of messages you will find in this kind of diagram. The synchronous messages, the asynchronous, the return, and the self message. And each one of them are used for different purposes. You will also realize that every return message is also an asynchronous message. Message displays interactions on a sequence diagrams, and there are 4 of them. Moving on. Solid arrowheads represent the synchronous messages, which means that if the caller sends a synchronous message, it must wait the message to be done. So when you put this message, you have to wait until something happens. It must mean that you have to invoke a method or something else. If a caller sends an asynchronous message, it can continue processing and it doesn't have to wait for a response. So every single return message is actually, as you can see, is an asynchronous message because the system can do some other task at the background that you might not know. The synchronous message means that you have to wait for something to happen, such as in order to verify the results, the database must process them. In order to happen, the verification to happen, you must wait the database call. So it is a synchronous message. It must happen in kind of like a live order. Where in the asynchronous one, this is not always the case. It can continue processing and it doesn't have to wait for a response. All return messages or replies, sometimes called reply messages, are asynchronous and it doesn't have to wait for a reply as they are the reply themselves. Self messages are also used in certain scenarios for validation or self response. While these messages are generally used for error handling, they are also used to show response for a specific operation or when the result of an operation is computed and returned. Self messages would be used for response operations, such as whenever you enter data invalid, you can show this in the figure. Like going up there into the original example, we can actually generate a self message there. It is possible that we can do a self message here and show the validation as well. So you can put a self message invalid username and password. We return a return message like this and say that invalid username and password. So it is possible that you can write here username and password not valid. And yeah, you can put it in there should you want to. This is too big. But anyway, you got the point. Any questions up to this point? These are the basics of the sequence diagrams, but this doesn't mean that they are the only components that you will see. There are many different components that you can see in the sequence diagram, such as it is possible to show error handling. It is possible to show conditions using what we call as fragments. So kind of like alternative scenarios. Basically, self messages are and conditions are kind of like alternative to one another. Conditions handle it better because they are fragments of the sequences and they show two different scenarios at once. These fragments divide the diagram into components, one that shows the valid operation, another shows the invalid one. Such as in here, you can see the fragment operation. First of all, the user inserts an ATM card. It asks for a password. The user enters a password. So up to here, everything seems in a sequence, but the alternative versions are shown in here. The card is valid, the card is invalid. So it's kind of like an if-else statement that you show where the password is successful, and you also show where the password is not successful, which is the incorrect. Okay, so this is not working. The other one is working. So it is one implementation showing you what kind of scenarios it can lead in one go. And you know that validation has to happen here. Okay, so that is the use of fragments. It is basically an if-else condition. It can also represent a loop or a limitation on the system. You can also use a loop fragment in a similar way. You just need to type loop, and while the students are on the list, you can select a list. The advisor can select the list from the SIS list of students, and then the student info can be retrieved. So you can detail the sequence diagrams however you like. It all depends on how you want to show the system. The more detailed it is, the better idea it gives you about it can help the developers to develop the system. They can understand what's going on. But always remember that this is an abstract representation of the system. It is not an alternative version. All right. The differences between UCDs and sequence diagram is that the use case diagrams, unlike the use case diagrams, the sequence diagrams can show error validation. Using fragments, it is possible to show errors or self messages. That's also an alternative. Sequence diagrams show fragments and constraints such as conditions, loops, where the use case basically ignore them and assume that everything works fine. Sequence diagrams show the order of interactions. This is very crucial. So the order of interactions are being displayed here, whereas the use case cannot do this. And finally, sequence diagrams are generally developed for the developers, where the use case are for stakeholders, managers who do not need to understand the system's uh, requirements, not as detailed as the developers themselves. Here is a use case diagram, a sequence diagram example, and I color coded it. So let's read it out. On an online registration system, students can select courses from the courses interface. So there's the student actor and there's the course interface, as long as they are registered to the system. So you are making the assumption that the students are registered. Once a course is selected, the course interface self-checks. Self-checks probably means self-message to find out whether or not there are enough quotas for that course. Once the self-check is complete, the selected courses are transferred from courses interface, which is the component of the system, to the timetable interface. Whenever I say interface, I mean the object interface. The timetable interface then notifies the students as courses are selected and your timetable is ready. Remember that every single return message should be an asynchronous message in the use case, in sequence diagrams. I already drew this before, so you will see the scenario here. I created a loop uh, in here, as you can see, and I assume as long as the students are registered, which is my assumption in the system. So I use an alternative fragment. My main actor here is the student. Student is basically selecting courses, and there are two interfaces. One that is the course interface, the other one is the timetable. It checks, the student checks the courses, checks the system will check the quotas. If the quotas are found, it will transfer the course and it will say courses is ready. Because no error scenario is given to me, I didn't put the error scenario here. So it's like it just assumes that once the self-check is complete, selected courses are transferred. So it doesn't exactly tell me if this, what happens if the courses are not basically selected, or what if the quota is not available there. Because the question didn't show me anything like that, I didn't display it. So I assume that everything works fine based on the question and show this. But technically, this self message is a check that's done on the system. It's kind of like an error check to check if there are enough quotas. Once this is done, it checks it and returns. Remember that every single return message is asynchronous. And you can of course see that most of the interaction is done in here, the course interface. It means that the course interface will probably be the most difficult to code in this kind of project because most of the interactions are being done there. Okay, so just by looking at this scenario, you can tell a lot of things. You can tell that users spend most of the time in the course interface, then the time interface. So this will be where most of the interactions would happen, and this will be the most difficult one to code. Okay, so you can basically put them into sequence and then divide them into further functional requirements. That is the use of sequence diagram to help you to understand your system visually. It doesn't need to be an alternative version of the system, but it does give you quite a lot of detail compared to the other two diagrams. So by doing the sequence diagrams themselves, we finish the behavior of the system. So far, we have the activity, we have the use case, and we have the sequence diagram. Up until here, do you have any questions? Hello, is anyone hearing me?
No question, sir.
Is everything clear? You're basically gonna draw these diagrams, so if you have any questions, ask it now. No, perfect. Cool. The last topic that I want to talk about today is the structure of the system. So we have three diagrams that focus on the structure. They are activity, use case, and sequence. We have one diagram that focuses on the structure, and we have one diagram that focuses on the state. And together they make UML. The next diagram that I'm going to show you is something that you are familiar with. If you have taken object-oriented class, which you should when you join this classroom, you know already what the class diagram is. A class diagram is the UML diagram that focuses on the structure of the system rather than the behavior. You can show relationship in between classes, but these are basically relationships such as a parent-child relationship or a relationship in between an interface and a class and so forth. In order to design a class diagram, technically the interactions must be precise. Otherwise, it might be difficult for you. The core of the class diagram is object-oriented design. Majority of the software that we use today are either designed using model view controller, which is the architecture that we use, or using some kind of object-oriented architecture that we want to separate how the data displayed from how it is structured, okay? And we can achieve this through object-oriented design. What we do in here is that object-oriented design is a designing system using self-contained objects and object classes, which allow the system to be formed as a stand-alone object. The idea here is to make the system expandable and reusable, so you can maintain the system. So you can build bits by bits and add components on the top of it. This is called gradual building up the project. So a project can start small and gradually you can build upon it. And using the object-oriented development and design, this can be achieved. At the core of object-oriented design lies the class diagram, which is used for the structure of the system. Class diagram is very basic. There are three parts of it. One, the name of the diagram, which can give you a hint about whether it is an interface, a concrete class, a parent class, or a child class, or an abstract class. Basically, the type of the class is indicated in its name. Then you have the second section, which is the attributes, where you can put variables with their modifiers such as public, private, protected. You can put static as well. You can put collections and constants. The final part of the class diagram is where the methods are placed. This gives the behavior some kind of meaning, but instead of the behavior itself, you focus on the structure of the behavior, such as the structure of the method, how many variables it's going to accept, what it is going to return, and so forth. As you might know, a class is a blueprint of an object, and each class can be told as a general definition of one object, like an abstract template, and the object themselves are the entities. Using this knowledge, you can generate objects from the classes. So you can do this part where you define a car class and objects are generated based on the template itself, such as Mercedes and Audi are cars, brands that we know and we use on the streets. We see them on the streets. But the class itself is the car. So every definition about the car being having doors, having an engine, having four wheels, and so forth, are defined in the class, and the specific properties for the car itself is given in the object. You should know these things from the object-oriented class. I'm just repeating them. The class is a definition of an object or object of the same type. In other words, a class serves as a template for an object. It includes declarations, variables, methods, and so forth. Using the class, you can generate the object itself, such as the properties can be defined. So you define the methods themselves in the class. The properties, such as variables, are also defined. And now the values that you give them are defined in the object, such as the eye color is blue, defined in the object. The weight, defined in the object. Length, defined in the object. The behavior also is defined there. Now, when you say sit, this dog will sit, and that is done in the object. What happens in the sit part is defined in the class. That is the core idea behind object-oriented programming. Objects are abstractions of real world or system entities. This time it becomes more and more real now. And the more diagrams you draw in the UML, the more you get close to the alternative version of the system. They could be sequentially or parallel, such as threads can run in parallel nowadays. They can even wait each other and so forth. And you can establish associations such as inheritance and polymorphism, concepts that you should know by joining this class. Okay. There is an obvious mapping from the real world of entities in the object-oriented design. So this diagram is a little bit different than the others because the others basically focus on more on the abstract representation. Among the diagrams that I showed you, this is the closest one to the alternative version of the system. It will not directly show you everything, perhaps, but it will be the closest diagram to show the alternative version of the system, hence why it is very often used by programmers alongside with the sequence diagrams. The sequence diagrams help programmers to understand the logical interactions, and the class diagram helps them to basically put them into the code. Okay, that is the advantage. Together, when they combine these diagrams, they will be most useful to the developers. As you know, the UML diagrams themselves is a de facto standard. Despite that we use these diagrams, they are not enforced to be used. But it is an international language that we speak in the software world. So it is highly suggested that you know UML before you finish your degree. Here's the class diagram example. You see the class name in there. You see the variables collection and structure, which we call as the attributes. And finally, you see the methods underneath the class diagram. So I'm gonna stop in here and re-invite you. I will finish it until the state machine diagram. Let's go back to BB, and I'm gonna finish this part, come to the until the state machine diagram, and we will finish the lecture. Okay. So I'm in the last 5 minutes. I'm gonna end up meeting, going to BB, re-invite you for the last time, and hopefully in 10 minutes we'll be done. See you soon. So welcome back again for the third and the final part for today's lecture. As I was talking about the class diagrams, I showed you the parts of it. In the first part, you will write the class name, which will give you quite a lot of hints, whether it is an abstract class or it is an class that basically designed as for a template for another class, or it is something that you can use as a parent class for another class and so forth. It could also be an interface. Give you a hint about that. The second part is the attributes, where you can put collections, you can put maps, you can put arrays, you can put variables and constant values. And the last part will show you methods. These classes can be associated with other classes using polymorphism, using inheritance, and so forth. Among the diagrams, this is the closest one to the alternative version of the system. The communication happens through interactions by methods. So basically calling a method from another class or calling a method in the object establishes the interactions. Most interactions in here are many-to-one relationships, okay? So if you establish a parent-child relationship, usually many children can be generated from the parent, but each child must have one parent. So in modern object-oriented languages, this relationship always meant to one. Although in C++, it is possible to generate many-to-many relationships as well, because technically each child can have more than one parent in C++. You can immediately tell a message and the object. If you know object-oriented programming, you know that after dot, this is the method, and this one is the object. Okay, I'm not gonna explain you object-oriented programming, because when you join this class, you should know it, and you should really know it, okay? And if you don't have anything about that, I would suggest you to register to my course and look at the slides or refresh your knowledge, because that is the content of another course. That is why when you receive this course, object-oriented programming is a prerequisite for this course. So technically, if you did not complete the object-oriented programming course, you shouldn't be taking this course in the first place, okay? There is the concept of super and subclass, again, a subject of object-oriented programming. Basically, a superclass is the parent and the subclass is the child. You can establish the many-to-one relationships in here, as you can see. In modern contemporary languages, the way that it goes is that this is the parent, so each one can have only one parent, but then they can have multiple children. That is the idea of, so within each segment you can have multiple children, but each child can have only one parent. This is the notation of how it is tracked. Technically, these can have the same variable. So if you have multiple parents, it might be difficult to tell which attribute is coming from which parent. And that is why this concept of multiple inheritance run through interfaces in the object-oriented programming languages. This is a very good diagram in terms of showing reusability at the programming level, but it also has some disadvantages. The more you get carried with the inheritance, the more complex the system becomes, and the more complex it is to be implemented. So you need to create a balance between this and the relationships, okay? I am going to stop here for today. I will do next week state machine diagrams, which is a very small subject. As you can see, it's not too much. It is also a diagram that not the least used among the 5 diagrams. I would say this is the one that is the least used one, because it is basically developed for the embedded systems rather than interactive online systems. Okay, so I would say the state machine diagram is the least used one. And the most useful ones to you are the sequence diagram, structure diagram, which is a class diagram, and also the use case diagrams. Those 3 are the most useful ones. Okay, Activity diagram also replaced the DFDs, as we know, data flow diagrams, and that is something that we're going to discuss in the next subject, which is called system architecture. Next week, I will also give you your second assignment, which you're going to submit to me by the beginning of June. All right, and we will have no exams in this course, as far as I know. In terms of midterm, you will not have it. So 50% of the course will be evaluated through projects, and another 50% will be done through an exam. As for the exams, I have no idea, no information how this is going to proceed, but my instincts and experience tell me that we're not going to go back to university anytime soon. So I think, this is my personal opinion, that the exams would be online. Okay, I don't think we're going to go back to university to take the exams. I think they should be online. And in that scenario, I will do a multiple choice exam instead of a comment one. If that is the case, I will prepare you a multiple choice exam. And I think giving marks in this term is also wrong, because we can never be sure if the work is done by the students or someone else. So I also suggested that for this term, the marks to be S or U, which means you pass the course or you fail, rather than getting an A, B, C, D, a mark. It's just pass and fail, because I think that is the most fair situation for you and for us as well, because it's almost impossible for us to assess students and put them in an order and to decide who got A and who got B. Technically, in a term, we can invite you and discuss with you your work face to face. We can read your body language, we can assess your knowledge and decide whether you did the work or not. But under these circumstances, this is extremely hard, and it's not really possible for big groups. It's very difficult. So I suggested to my dean that this should be an SNU term for you, okay? And that is the most fair situation. On 15th of May, I am expecting an announcement from the higher education institution in Turkey and also in Cyprus to announce us that how we can proceed with the final exams. I hope that they will not postpone the exams to September. I hope that the exams should be done within this term. And if that is the scenario, we will do the exam online, all right? I'm gonna stop in here for today. We already done almost 2 hours course. Do you have any questions before I end up the lecture for today? Tomorrow we will meet for a short session. It will be shorter than this for sure, to finish the state machine diagrams. And that's what I'm gonna do in the next lecture, okay? Which is tomorrow. It will be shorter, it won't be like 2 hours. I just wanna finish this subject so I can prepare your coursework for you. Thank you for coming, guys. I really appreciate that you are attending every week, all right? And have a lovely day. I'll see you guys tomorrow. Take care.